But T-minus 10 minutes and counting right now. The good news is we continue to be on track for an on-time launch, tracking no issues at the moment. This is a Dragon mission, which means we are constrained with an instantaneous launch window. What that means is Falcon 9 must lift off at this T0 mark. We don't have an open window with which to recycle the countdown and go again. It's instantaneous because we're trying to time our launch to the point where the International Space Station will be just about directly overhead Cape Canaveral, and then Falcon 9 and Dragon will be basically trying to catch up to the space station with eventual capture at 4 a.m. Pacific time on Wednesday. The most significant portion of today's countdown started at the T-minus 70-minute mark, where our launch control team was pulled at Cape Canaveral to enter into the propellant loading sequence. Now, as you may recall, in order to make fire, you need 3 elements: fuel, oxygen, and an ignition source. Our fuel for Falcon 9 is RP1, that's refined kerosene. And as we're sitting right now, both our first and second stages are nearly full of RP1. We will continue to top them off up until about the T-minus 5-minute mark on that first stage. We also carry densified liquid oxygen that's cryogenically cooled. That's actually those clouds coming off the rocket. That's the liquid oxygen boiling off. Right now on the pad, we're sitting at nearly full of liquid oxygen on our first stage, and about 95% full, 90% full on our second stage. We will continue to load liquid oxygen up until about the T-minus 3-minute mark. We also load on helium on board both stages. That's what we keep the tanks pressurized with as we're emptying it of propellant. Dragon, meanwhile, ready to go. It began its auto sequence at T-minus 35 minutes. That's where it begins its coordinated timing. It's moving into internal power, just transitioned that period right now. Everything looking good to go there. Range, also ready to go. Weather, looking pretty good. We were tracking some anvil clouds earlier, but it looks like any constraints that could affect today's launch will be actually after our T0 mark. Weather team is continuing to monitor these anvil clouds, but as of right now, no constraints for today's mission. So overall, we continue to be go from Space Launch Complex 40 at Cape Canaveral Air Force Station. "11 years ago, Dragon was just a design on a piece of paper. But in 2010, SpaceX became the first private company to send a spacecraft to orbit and return it to Earth. 2 years later, in 2012, soon after I started at SpaceX, a Dragon became the first privately developed spacecraft to visit the ISS. Since then, we've made a total of 13 trips to the space station, and we're under contract with NASA for a total of 20 cargo resupply missions. We are currently flying cargo to the space station, but ultimately, we will fly astronauts on crew missions, with our first crew demo mission slated for later this year. Our Dragon mission today is conducted in close coordination between NASA Mission Control at Johnson Space Center, also known as JSC. And on your screen, you're looking at a live view of Mission Control at JSC in Houston, Texas. The team at JSC there are monitoring today's launch, as well as coordinating the activities with our international partners of the space station. Dragon is packed with almost 5,800 pounds of research, crew supplies, and hardware headed to the ISS and its 6 crew members. Let's take a quick, closer look at what we have on board Dragon today.
SpaceX's 14th commercial resupply mission to the International Space Station will mark the first opportunity of 2018 to replenish this U.S. national laboratory in low Earth orbit with new and exciting research. Let's learn more about some of the featured investigations and facilities that are destined to station as part of this mission.
490 Biotech will examine anti-cancer therapeutics through a novel bioluminescent kit. This research could have far-reaching impacts on the drug development process, to include the timing of when therapeutics come to market. 2 student investigations as part of the Genes in Space flight competition will be evaluating various DNA experiments aboard the space station. Students from across the country have the ability to submit DNA amplification experiments through this program, which is sponsored by the Boeing Company. The Materials International Space Station Experiments Flight Facility, or MISSY, was developed by Alpha Space. This exciting facility will enable academic, commercial, and other government agencies the ability to put materials experiments on the outside of the space station, exposing these experiments to the extreme environment of space. The multi-use variable gravity platform developed by TechShot includes 2 internal carousels that simultaneously produce artificial gravity. This facility can be used to conduct research in space with a wide variety of sample types. A CUBE satellite mission developed in partnership with NanoRacks will focus efforts on the ability to remove debris in low Earth orbit. The mission will deploy 2 CubeSats as artificial debris targets to demonstrate technologies such as net capture, harpoon capture, and vision-based navigation.
This mission provides an assortment of research on space station that will benefit life on Earth, and will also bring new facilities to the International Space Station to further enhance our capabilities in low Earth orbit. And we wish our partners at NASA, SpaceX, and all of our principal investigators the best of luck for a great year of research in 2018.
Follow @ISS_research on Twitter for more information about the science happening on station. Along with bringing cargo to the ISS, an equally important function of Dragon is to return back experiments. Dragon is the only operational spacecraft capable of returning a significant amount of cargo to Earth. The good news is, Dragon has given us the thumbs up. Its vehicle is ready to go to space. And with just under 2 minutes and 40 seconds in today's mission, Falcon 9 has finished topping off its propellant loading. We've wiggled our engines, doing the thrust vector control checks on both our Merlin vacuum engines, as well as the 9 Merlin engines at the base, bringing us into T-minus 1 minute, where Falcon 9 will enter into startup. The rocket will take control of the countdown at the T-minus 1 minute mark. So we're going to go silent over here on the webcast and let you listen in to these final 2 minutes of today's mission.
Stage 2, LOX load is closed out. Falcon 9 is on internal power. Vehicles in self-align. Gas closeouts.
AFTS is ready for launch.
Falcon 9 is in startup.
Ground gas closeouts.
Dragon is in startup.
Launch directors go for launch.
T-minus 15 seconds.
Falcon 9 is configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition.
Falcon 9 is on its way to delivering the Dragon spacecraft for its 14th commercial resupply services mission. Coming up in about 10 seconds, we have max Q, maximum aerodynamic pressure. That's one of the highest stress states on the vehicle.
Vehicle is supersonic. Vehicle is experiencing maximum dynamic pressure.
Just passed through max Q. This first stage burn will last for about another minute and 10 seconds. As we leave Earth's atmosphere, you'll notice the exhaust plume gradually expanding.
And back engine chill.
And just heard the call out that the upper stage engine, the Merlin vacuum, has begun chilling in, similar to how we chill in the 9 Merlin engines before the initial liftoff of the Falcon 9. Now coming up in rapid succession, at about T plus 2 minutes and 40 seconds, we'll have MECO, our main engine cutoff, followed by stage separation, followed by ignition of the upper stage engine. Let's watch.
We have MECO.
Stage separation confirmed.
And back ignition.
And what you just saw there was a successful shutdown of the 9 Merlin engines of our first stage, followed by separation of our first stage from our second stage using 4 pneumatic actuators at the forward end of the stage. And then after that, you saw ignition of our upper stage engine. You may have noticed a piece of metal flying away from the engine. That's a stiffener ring that protects the larger Merlin vacuum nozzle on ascent. That's totally nominal. And on the left side of your screen there, that's actually the Dragon nose cone that it's popped off and is falling back to space. Dragon nose cone falling off, totally nominal. That's exactly what we want to see. We use that